Okay, we're back. So we just a second ago covered summary 4, and I had a few students emailing me over the weekend saying that they're still having some issues with summary 3, and that's okay. It's a challenging summary. I did manage to post a little YouTube video on the polynomial and the exponential portions, because I skipped through that a little bit when I went over summary 3 last week. I'm going to click on it just to verify that it works.
Oh
yeah, I watched it.
Okay, so it looks like it's going. It's a little small on the screen.
Polynomial and exponential functions.
I think I got it
In
big enough.
Microsoft Excel. Okay, so
That it's legible. I did a
what you're going to see
polynomial
after you plot
equation, in fact, a quadratic
curve fit, a
equation.
trend line.
And rather than having 2 coefficients,
So it's going to
there's
be
an M,
quadratic
B, you have
form.
3 coefficients, and the
So in this case,
exponential,
we're
you
looking
have
at
2
n, which is
coefficients,
going to be the
one
population as a
out
function of
front
t
and then
time,
one time constant.
and you'll have
So I'll just
a quadratic
go over
form,
that
n of t
again
equals at
with
squared
the
plus
example we
bt
gave, just
plus
to
c.
drive that home. Unless there are any
So
other
a,
specific.
b, and c are going to be your 3
So I
coefficients here.
think it's important to focus on this because
And you'll
there's
just see those,
subtleties there.
yeah, let's just take this, we can copy it, paste it.
It's kind of weird. I
It'll
mean,
look like this.
get
In this
infinite
case,
loop
C,
going.
it says
YouTubing
20,000.
myself, YouTubing myself. Okay. Okay, so 101.
What's that thing coming up in November, where you got a whole day's plan lined out, 8 o'clock breakfast, 9 o'clock, everything, what exactly is that?
Oh, I'll show you. So the question is, have I lost my mind or not? No. I put it on an Evite for a zero waste demonstration at my house. This is a slightly different but related topic. I'm working on my second book right now. Since you asked, I'll show you what that's all about. This is the title of the book. So I've been zero landfill since 2010, and it hasn't been easy. But if we sort of click through here, I think I'm like, well, almost 20,000 words into it, 30 or 40 figures.
Really, you have personally not produced or taken anything to landfill or waste? You found a way to dispose of it properly and to do all that for 5 years now?
Yeah, in fact, I've been, digging through my neighbor's garbage, taking their clothes to Goodwill for them, picking up the grass, the lawn bags, turning that into soil in my backyard, taking all the thin film plastics, baling that for waste to energy, I think, glass, aluminum, I mean, that's, it's doable, yeah. So anyway, and I think I've got a few pictures, I tied in a little bit with global warming, show, like some of these landfill disasters happening around the planet, show kind of my own sort of bio versus techno recycling webs that are, present. There's Missoula's landfill, sorting strategies, kind of how I think the money should flow. There's Goodwill. There's me grabbing lawn bags from my neighbors to turn into soil. So, this is fossil fuel free as well. I'm not, burning ancient hydrocarbons to move current hydrocarbons. This is me moving some biomass up the Rattlesnake with human power. Anyway.
That's neat.
Yeah, so anyway, so at my house, here's just my own little composting and chicken feeding station in my kitchen, showing that it's not that nasty. You know, it's doable. But what we're going to do at my house, though, is just some projects, just showing, you know, how I've done the zero landfill thing, and then how I've been able to build with renewable materials. So that's all it is, just one of those Missoula kind of events.
That's awesome.
Yeah.
And which day is that?
It's November 15th.
Is that a Saturday?
I think it's a Sunday. I think it's a Sunday. Let's check. Yeah. Yeah, Sunday the 15th. Zero Waste Day at 8 Columbine. And I'm going to treat it as a learning opportunity, too. I go to these zero waste meetings at Home Resource, and somebody's always figured out some new gadget to build with, you know, old utensils or old bottles or, yeah. Okay, so summary 3, example. Okay, so here's the exponential. I'm going to leave these equations there and just start from scratch with some fresh data. So let's just say we have time here, we have number of people here. A few people asked, hey, can I do it every day instead of every 2 days? Yes. Someone else asked, can I do it every 3rd day instead of every 2 days? Yes. That doesn't matter. It's mainly just, can you run through the exercise of making an extrapolation in Excel? So here's 0 days, 2 days, 4 days, and I'm going to make up some numbers again. So I'm going to start with 7E9. I'm going to say that equals this times, I'm just going to say 1.1. So the population went up, and I'm going to say this equals that times 1.2. So those are some pretty big population growth numbers, but anyway, so once you've got your data in there, you're going to come in and insert a chart. And again, I would like you to use this one, which scatter with straight lines and markers, because up to this point, we aren't assuming that we actually know what's going on in between these two data points. We took that data point, we took that data point, we took that one. It could be that, gosh, a whole bunch of people were born, a whole bunch of people, I mean, it could be anything in there. It could, you know, all over the map. The straight line just helps you visualize the data and know that it's one set, just like we saw in the nuclear reactor paper. Okay, so from here, what you can do is I'm going to copy this graph. I'll paste it over here for later. Looks like I put my figure over the top, so I'll put these two guys here, put this one over here. So now that I have 3 data points, I can right-click on the line, I can add a trend line, and in this case I'm just going to add the polynomial. It's in order 2, which is correct, and I am going to want to display the equation on the chart. Okay. And now I can come in, make this a little bigger, and I'll even make the font a little bit larger. Let's go up to 20-point font, see what happens. It's maybe a little too big, but not too bad. Okay, the other thing I'm going to have to do on this so that I can get the data I want is to format the trend line label and give that a few more significant digits. In this case, it's pretty simple because when I type those numbers in, I didn't have too many, I only had one significant digit. I just typed in 7 billion. But in your data, you're going to want to use 3 or 4 of those significant digits when you put your coefficients in. So now I can see that, and so this first number, 105 million, is my A coefficient, so I'll just do that down here. So A is 105,000,000. B is 140,000,000. C is 7 billion. 7,000,000,000. And let me just double check. Go ahead and format this. Control 1, turn that into a number. Don't need the decimal points. Throw a comma at it. Okay. So I verified that that's my A value, that's my B value, and that's my C value. And those correspond to A is T squared, or A is the coefficient on T squared, B is the coefficient on T, and C is the 0th order or constant coefficient in the example I gave previously. All right. Now, to do my extrapolation, I'll just type in 60 days here. And my model is such that I can now say that in 60 days, based on this quadratic model, the population should equal A times 60 times 60 plus B times 60 plus C. Okay, now obviously this is pretty aggressive population growth because I had it in 2 days, the population increased by 20%. So in 60 days, we're on our way to 1/3 of a trillion people. Good thing we're humans and not bacteria, I guess, reproducing at such a fantastic rate. But what we can do from there, the data being as it may, I made that second graph ahead of time, and so I can click on that little curve and then just drag this down and drag this down, and there's what it looks like. Yours won't look quite that extreme, but so that's that. Okay. Now I can also take this chart and copy it. So once you've done the linear and once you've done the other ones, the polynomial, the exponential is pretty simple. It's almost just copy, paste, change one button, and you're done. So let me go ahead and do that too. Copy, paste. Take this one, copy, paste. But let's go ahead and just put that data over here. We'll call this polynomial. And we can take this entire chunk right here, copy it, paste it there, and call this the exponential. Now, your initial data is unchanged. We'll just keep that we can keep that as yellow. This is your calculated value. I think we were using red for that before. These are the constants that you pulled, so you can make them blue. For exponential, these are going to be different though. Okay. Now I'll just change this little title up here to be. I accidentally deleted it, but I also want to let you know when you put these figures into your Microsoft Word, it's usually a good practice to not have a title up here at the top. Just leave that for the caption in your figure. Just keep the plot itself as clean as possible. I'm not going to micromanage you on that, but anyway, I'll just put this. This is the exponential, or sorry, this is the poly, and this is the exponential. Okay, now all we should have to do, I just clicked on the trend line on the exponential plot. It used to be polynomial because I just copied and pasted. If I just click it now to exponential, it changes for me. Done. And now I've got a new number, and it could be that if I format the trend line label and say, okay, you are a number, I'm going to give it a few more significant digits out there, and you can see that 0.7 that was sitting right here is now 0.0694. And I do encourage you to use 3 significant digits, and now I have 3 significant digits, 694. Before I only had 1, 7. Okay. So, should be able to now take those 2 numbers so now I'm looking at the only 2 numbers I have are A and T, and I'm going to change this little t to be the Greek letter tau. Tau is the more conventional symbol for time. I mean, it's both time. You know, they're both measuring time. It's just that the little t means like seconds, days, etc., and the tau is more or less what fraction of that. You know, what fraction of your day, what percentage of your day. That's the best way to think of that time constant. Okay, so from here, we can pull those 2 numbers from the trend line label. So 6, 8, 9, 9, 2, 1, 9, 2, 4, 9. And T we're looking at as 0.0694. Okay. Now let's go in here. We still have the polynomial expression in there. It's wrong. So this equals A times EXP. EXP is the exponential function. It's e to whatever we tell it. And what is it? Well, it's e to this number, and I'll change that so it's not actually saying 0, times this number. It's the time constant multiplied by the time. Enter. Let me reformat tau, so it's a number with 4 decimal places. That looks a little bit better. Okay, now we can see that the exponential model predicts a greater population than the polynomial model. And almost certainly both of them predict greater populations than the linear model. So your write-up or your interpretation for summary 3 is more or less which one's more accurate and why. The other point of the exercise here is to get to be able to use Microsoft Excel to predict the future. Like who do we want to be able to predict the future, right? I mean, that's really, in a lot of fundamental ways, the true value of science. You know, knowing what happened in the past, looking what's going on right now, and helping us look towards the future. Okay, now so the last thing to do on this exponential curve, it was plotting the polynomial. So all we have to do is drag it over here, drag this over here, drag this over there, and now you can see it's plotting the exponential. So not the most exciting graphs to look at, but if we look right here, the polynomial was coming in at 4 times 10 to the 11th. That's 400 times 10 to the 9th, so 400 billion, whereas the exponential is coming in at 450 billion. And you'll have, once, if you dig into the scientific literature, and this is also not completely unlike some of these climate change models that people spend a lot of time haggling back and forth. I mean, you start to extrapolate, and how far into the future can you really predict based on what you know now? So, and there have been people spend their careers, debating and deciding which model is the most appropriate. Okay. Any questions on that? I think now you kind of know how to work the math. No? Watch it again in slow motion. I mean, there was no sleight of hand there. I mean, all I was doing is letting the computer do the hard work and generate the equation for me. The equation itself is just as I showed here.
Is is Naomi know this stuff pretty good?
Oh, yeah, yeah.
Okay, what are her office hours?
They're posted on the wall.
Okay.
Yeah,
Cool.
she's in every day. Yeah.
I'm definitely gonna come down and get some serious help because you've been speaking to me.
Well, you might, Naomi's incredibly busy right now with registration for next week. But there's two or three really talented people in the Learning Center. Do you have Training Bayless's and Debbie Sloan's contact? Let me get everybody that right now. Okay, so here's one more, couple more resources for you. I'm getting some good signals here again. Let me see if I can find.
Are you just gonna email those?
Yeah, I'm just going to give them all a heads up right now. I know Training Bayless is in here somewhere.
Because I've got tons of time now, I closed my shop, but I'm
Oh,
definitely
nice.
gonna need some help getting going on this.
And there's Betsy. Okay. So I'm just going to send her that. I'm going to CC. So Betsy runs the Learning Center. She's got the hours for Training and Debbie there. I'm going to go ahead and CC everybody in the class. So everyone's got the email. Fall 2015, emails 101, all copy, paste. So again, here's Debbie, here's Treenan. I'm actually going to pop back out into the course. And I think what I should probably do, polynomial, the exponential model. I'm going to give her the I'm going to give her the YouTube
How to
link.
plot the polynomial and exponential functions in Microsoft Excel. Okay, so what you're going to see after you plot a curve fit, a trend line.
I'm also going to give Betsy the two YouTube links. So I think a lot of times, if the tutors in the Learning Center understand the exercise, and they will, I mean, they know exactly what linear models are, polynomial, exponential models. Once they get it, they won't have a problem helping. A lot of times you come in there cold, like, I don't even know what the assignment is. Well, I'll send that to them. Let me just find the lecture. Oh, here it is.
To cover summary 3. All right, so we just went through a really cool oil problem, converting barrels to gallons, looking at discrepancies between gallons consumed versus the amount that we might potentially make
And I'm
from
gonna
the
send
total
her
U.S. oil production as well as
101.
U.S. oil imports. Now I want to take you to summary 3.
Summary
Let's get up
3
into the
instructions. So
website a little bit.
Betsy has
Summary 3 is a
summary
little bit
three
different
instructions.
from the
She's got
other
both YouTube
four
videos,
summaries.
the example.
One of my main
She should be able to share that
motivations
with
for
Katrina,
giving this
Debbie, and so if you need more help
summary was
outside
to
the classroom.
give you some exposure to Microsoft Excel. It also
And
gives
another
you
thing I'm
some
noticing here,
modeling experience.
folks, is that for some reason, I am only seeing one post to the forum. And, you know, if you're having, the one post is from Tim Chester saying, if you're having problems, why aren't you using the wonderful World Wide Web as your solution? So, yeah. Good question.
Now, I asked you to take a snapshot, like how do you take a snapshot?
One second. What's the question?
How do you take a snapshot?
What do you mean?
Because I assume
I'm
since
not
the
sure.
data is constantly running, it says take a snapshot, and it wants you to be carbon emissions
Oh,
and population, but I don't know how to take a snapshot.
Oh, I see.
do it on my phone.
oh, okay. Oh, I got you. So the question is, let me,
The plus thing that's next to it?
okay, so the question was, how do I take a snapshot of the data? Is that the question? Yeah, so if you're looking for the current world population, you know, so I'm looking at it right now and I see 7,387,433,400 and change, right? So a snapshot to me means I come in here,
And just take one of those numbers as you see it.
yeah.
431.
Yeah, exactly. So I'd go back here. It might be possible to actually copy this number, I don't know. Let me see. Copy. Paste. No. Nah, that's some kind of dynamic element. No, I would just type 7,387. I can't remember that. So 7,387. Go back. Get to it.
But people need to start dying fast.
433.
We're up 70 million right now on the year.
578. So I would just that, 578. That's a snapshot. And then just to make sure you got it right, do a control 1 number. Dink, 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 yeah. That is bizarre. I mean, I look at that, it is bizarre. I mean, it's mind-boggling. I'll go back and I'll tell you why. Because I first had the idea to do this assignment, let's see what summary 3 looked like a few years ago. Population, yeah. So this is, another student, Energy 101, fall of 2011. So he was going to see, what's the population, the CO2 going to look like in December, just 4 years ago. Yeah. Like an entire United States of America has been added to the planet in 4 years. We're not a small country. We're 300 billion people, or 300 million people, and in 4 years, there's an entire new US of A has been born. I mean, there's a USA that's between 0 and 4 years old on the planet right now. It's just baffling. And there's the other numbers here, 27 million tons of CO2. Let's just look at that and see where it is now 4 years later.
It's at 30,638,305,000. So it's went up 3 billion.
Yeah, so it's 10% higher. The numbers I've been seeing is that by 2020 we're on pace to go over 40 billion tons by on an annual basis, and that we're also on target to burn 9 billion tons of coal each year. That number is rising too. So something to think about in a big way. Okay, let's pause. I think we spent enough time on summary 3 now.